Hi there, welcome to Mini Math Lessons. Working in Classpad.net, and here's the landing site. Definitely create an account. It's free all the time, students, teachers, and it lets you save any activities that I'm sharing today, and it also lets you create your own or find ones that are done. We have hundreds of ready-to-use activities. So be sure you create an account. Start exploring. You can look at the activities here. I'm going into an activity which is shared in the description below, but this one is about musical frequencies. So it's just an activity that's been adapted from our Fostering Mathematical Thinking with Music, and it's about looking at the pitch of the chords as you go up and down a keyboard, but also similar to other musical instruments. So it's about the 12 notes that are on a piano. So the 7 white keys, and then the 5 black keys. Even though there's 2 notes here, they're really the same note. Just depends whether you're going left or right. So it's basically the students are given, here's your 12 notes. So you'll see that the first 12 are those notes. And as we go in the table, they repeat themselves. So I'm going to look at this table here, and I can kind of scroll up. It's the same 12 notes 3 different times. And so it describes right here notes 1 through 12. So basically we've numbered the notes, even though they're repeated every 12. We've numbered them 1 through 36, and the numbers, the first 12 represent the octave below the middle C octave. The middle 12, so notes 13 through 24, represent the octave at middle C, this one that's represented here. And then the notes numbered 25 through 36 represent the octave above middle C. So what we're really doing is comparing 3 different octaves. The middle C, the one at middle C, the 12 at middle C, the 12 below middle C, and the 12 above middle C, those 12 notes. And then we're looking at, so each note's numbered, and we're looking at the frequency as we go from the lowest to the highest. What's happening is their relationship. So the first thing they're asked to do is make a scatter plot of the note number. So remember, we're going from 1 to 36, kind of up the keyboard if you look at it that way. So they're going to select the column B and column C, and they're going to make a scatter plot. So is there a relationship? And as you see, as we move up, so this represents, and I'm just going to kind of move my scale so we can see it a little bit better, see the axes. So as we move up the notes, the keyboard, we think about it that way, so the first 12 are here in this lower end, so they have a lower pitch, a lower frequency. The last 12 are in the higher octave, right? And they have a higher frequency, so a higher pitch. And so when we're talking about pitch, we're talking about what we hear. We hear lower notes and we hear higher notes, and the frequency, the vibrations, if you want to think of it that way, is much higher in the higher notes. It's moving much faster, and so this is connecting. So students are then asked to, can you come up with an equation for this? And they could do it with a regression. So they're exploring that. So then as they move down from that, so they're writing their observations, they're looking about their numbers, then what they're asked to do is, well, is there another relationship between the note number and the difference in the frequencies? And so one of the things they're asked to do is to calculate the first difference. So what does that mean? Well, it means here's the second frequency, subtract that first one, so the difference is 8. And so you're basically taking the difference of 4 subtract 3. So 156 subtract 147, that's where this 9 comes from. 165 subtract 156, that's where this 9 comes from. Is there a pattern in this? And so they're going to collect that data, create that data, and then they're going to graph those differences. And so I'm going to pause for just a moment to complete that so that we don't waste time watching me do that, and then I'll come back. All right, so we're back, and even as I'm doing this pattern, I'm kind of seeing patterns like it's 8, 8, 9, 9, 10, 10, 11, and 12, 12. So it's going up. And as we get into the higher frequency, it goes up a little, it jumps by 2s instead of 1. So things like that I'm noticing. So now they're asked to actually graph it and see what the relationship is. So we're going to click the note number and the first difference, and we're going to make another scatter plot. And let's actually change this color so it looks a little nicer. And what you notice is it looks very similar. We can even bring it up to the first graph so we can compare them next to each other. They look very similar, almost identical really, except for the numbers obviously. So they have the same relationship, so they're growing about the same, right? So these are the different things that we are going to be looking at in this activity. Let's bring it back down. Nice thing about Classpad is you can move things where you need them to be. So there's that scatter plot. So then they're gonna, write about what their observations are. How does it compare? What do you notice? Same different relationship going on. Then they're gonna start looking at like other types of relationships. What do you notice about the frequency of corresponding notes at different octaves? So let's go back up to our table here. Let's go to this table. And if we look at the corresponding frequency, so like say C prime here, let's go up here. Let's look at C, the frequency, and let's pull up a calculator sticky. We've got C at the lower octaves at 131, and if we compare that to the C at the next octave right here, 262, what do we notice? Well, it's 1/2, so the lower octave is half of the next octave. So let's make a conjecture. Is this octave here in the middle C, its corresponding C in the next octave, the higher octave, would be at 25 here, right? 523. So are they corresponding? Are they having the same proportional relationship? So let's see. So we have 262, and what did we say that was? 523. And if we look at the decimal, it is about half, a little bit more. So what we're noticing is that they're proportional. As you move up the octaves, the relationship is lower octave to middle C is half, and then middle C to higher octave is half. And so there's this doubling happening every octave. And so, which means would this lower octave compared to this higher octave, which is 2 away, be 4 times larger? Well, let's check it out. So we can do corresponding notes, and we're going to assume it's 1/4, 1/4 the size, or the higher octave is 4 times larger. So it's this really nice proportional relationship, and this is why music is very mathematical. So we're thinking about the fractions. So they're going to continue to explore this and kind of develop some relationships. You'll notice that there's already a graph of what they did up ahead, and now they have to try to come up with a model, a mathematical model that represents this. So lots of math that they're doing to connect these notes and the frequencies and the pitch.